This SOS video is about multiplying polynomials, a polynomial times a polynomial. So vocabulary reminders, the distributive property, remember we need to take the outside term and multiply everything, all the terms in the parentheses by the outside term, not just the first one we see, but all the terms. A box diagram is a table that organizes the products, the results of the distributive property. So I'll show you how to do that. And then the simplest form of a polynomial is our answer when all like terms have been added. So when polynomials are multiplied, you can either use the distributive property or you can use the box diagram to organize the information. So I'm going to show you how to do each. Let's work with the distributive property only. I have a binomial times a binomial. So I'm first going to take 4x, my first term, and everything in the second set of parentheses I need to multiply by 4x. So 4x times 2x is 8x squared, and 4x times a negative 3 is a negative 12x. There are no more terms left here than I can multiply by 4x. So then I look in this set of parentheses and I realize I still have a positive 6 left. And everything in the second set of parentheses needs to be multiplied by 6. So 6 times 2x is 12x. I'm going to put this underneath here because these are going to be my like terms. And a positive 6 times a negative 3 is a negative 18. And now let's just add this. So I have 8x squared. A negative 12x, positive 12x is 0. That's our inverse property of addition. So I don't say plus 0x, I just leave it alone. I can put a line through it to show that they are opposites of each other. And minus 18. That is my final answer. Now, please put an asterisk by this next one. Whenever you see a binomial to a power, the very first thing you need to do is rewrite this as a factor that many times. So I write x plus 3 as a factor, which means I'm going to use it to multiply. And I write it again because I need to write it twice. Now I'll use the distributive property to multiply. So I take this first one. This is really x to the first. So x to the first times x to the first is x squared. And x to the first times 3 is a positive 3x. Now there's nothing left in here for me to multiply by this first term. So I continue on. I have a positive 3 in this first set of parentheses, and every term here I'm going to multiply. So positive 3 times x is another positive 3x, and a positive 3 times a positive 3 is a positive 9. And now let's add them. X squared, positive 3x and a positive 3x is a positive 6x plus 9. That's our trinomial. That's our final answer. Okay, taking a look at the next one. I have more terms, but that's okay because remember in math, we only ever multiply two things at the same time. So I'm going to take 3x squared and multiply everything in this parentheses by 3x squared. So 3x squared times x to the first is 3x to the third. Remember, when I multiply variables, write the variable and add the exponents. 3x squared times negative 4 is a negative 12x squared. Now there's nothing more left here to multiply 3x squared by, so I go to the next term, 5x. 5x times x to the first is 5x squared, and 5x times a negative 4 is a negative 20x. And there's nothing more left to multiply by 5x. So finally we have negative 2. Negative 2 times x is a negative 2x, and a negative 2 times a negative 4 is a positive 8. I put these underneath each other because they're like terms, and I know when I'm going to add them, I'll add those together. So nothing else for cubed, so I write 3x cubed. A negative 12x squared and 5x squared, different signs difference, so I subtract that, and I keep the sign of the one with the highest absolute value. So that's negative 7x squared. Negative 20x, negative 2x, same sign sum. So I add those together and I keep that sign. And finally, plus 8. And that's using the distributive property to multiply polynomials. Okay, now let's use a box diagram method to multiply these. In a box diagram, we're going to have a little box to keep the results of each of the items we multiply. So I'll start off with here. This is 2 terms, this is 2 terms. So I'm going to draw a rectangle. Since this has 2 terms, I'm going to split this top into 2. And I'll write 7x minus 2. Now on this side, I'm going to split this side into however many terms I have. I also have 2. So I'm going to cut this in half. And this is a positive 2x and a positive 5. So that's how we set this up. Now remember, since we're going to multiply, we want to remind ourselves that the invisible exponent for that variable is a 1. If you do not see a 1, if you do not see a number, you're going to write the 1. Okay, so let's multiply this term by this term. 2x times 7x to the first is 14x squared. When I multiply the variables, keep the variable and add the exponent. 2x times a negative 2 is a negative 4x. 5 times 7x is 35x. And 5 times negative 2 is a negative 10. And now I'm going to combine like terms. I start off with my highest exponent. That's x squared. There's no other x squares, so I write that down, 14x squared. Then I look for my x's. So I have 35x and a negative 4x. When I add that together, it's a positive 31x. And finally, negative 10 is my constant. All right, let's use a box diagram to multiply these. So again, I'm going to draw a rectangle. And I like to put the most terms on the top because this is longer. So this has 2 terms, and this has 3 terms. So let's put this on top. I can change the order, commutative property of multiplication. So this is 3 terms, 1, 2, 3. So I'm going to divide this in 3 parts. 2x squared minus 4x to the first plus 1. This side, I just need to fit 2 terms. So I'm going to split this in half. And this is 8x to the first and a positive 3. So you're going to stop the video, multiply these, and start the video again and see how you did. Remember, we were multiplying each of these terms. So check to make sure you have this correct. And now let's write this in standard form. So the highest exponent is a 3. I circle that. I don't see any other cubes. So this is 16x cubed. Next up is x squared. So positive 6x squared and a negative 32x squared is going to give me a negative 26x squared. That has the highest absolute value. And then we add the x's. A negative 12x and a positive 8x is a negative 4x. And finally, my constant is a positive 3. Now, what about a word problem? Kara ran laps for track practice. Emma ran 6 more laps than Kara, and Angie ran 3 laps less than Kara. Write an expression, so remember expression, not an equal sign, to represent each person's amount of laps run in terms of x. So when we write these, we start with the person we know least about. All we know is that Kara ran laps. So we're going to say x, and that stands for the number of laps that Kara ran. Well, Emma ran 6 more laps than Kara. So if Kara is x, 6 more laps than that would be x plus 6. Angie ran 3 laps less than Kara. So if Kara ran x laps, 3 laps less means I need to subtract. So Angie would run x minus 3 laps. Now you're asked to represent the product of all the laps run by the 3 track members as a polynomial expression, no equation, in simplest form, which means once I multiply this out, I want to make sure that I have combined like terms. And what do we say? No problema. Okay, we've got this. So the product of all the laps run by the 3 track members. Well, here's the number that Kara ran. If I have more than one term, I'm going to put parentheses around that. So we're going to multiply Emma. And then Angie has more than one term. I'll put parentheses around that. And we're going to multiply this. Now, the associative property says I could multiply the first two and then multiply by the third. Or I could multiply these two first and then multiply by x. Well, it's going to be easy to multiply this as long as you remember to put your answer in parentheses. So x to the first times x to the first is x squared, and x to the first times 6 is a positive 6x. But I still need to multiply this by x minus 3. So let's keep this answer in parentheses and x minus 3. I'm going to do this with the distributive property, but if you want to do it with a box diagram, you could do that as well. So x squared times x to the first is going to be x to the third. X squared times a negative 3 is negative 3x squared. There's no more left to multiply x squared by here, so I start off with 6x here. 6x to the first times x to the first is 6x squared. I'll put this underneath because I know I'm going to combine them pretty soon. And 6x times a negative 3 is a negative 18x. Okay, we're ready now to add this. No x cubes besides that, so we have x cubed. Negative 3x squared and a positive 6x squared is a positive 3x squared, and then negative 18x. And that would be the amount of laps run by all 3 track members. So you have learned to multiply polynomials and the fact that we could use the distributive property or the box diagram to get our final answer. So this has been the SOS video on multiplying polynomials.